Hello students, today in your geometry class, you're going to be working on similar polygons. So let's work on a couple quick practice problems. So for number one, work on number one and work on number two. Hopefully you've paused your screen and now you're just checking for answers. If you did this right, x should have turned out to be 50 divided by 15, or 10 thirds. Number two, when you take the cross product, you would have gotten 15 times the quantity x plus 4 equals 50. That would have been 15x plus 60 equals 50. We would have gotten 15x equals negative 10, and x equals negative 10 fifteenths, or negative 2 thirds. So at the end of this lesson, you should be able to identify polygons, whether polygons are similar, and what some of their lengths might be. So one of the important things that we're going to go over are similar and similarity ratio. Two figures that have the same shape but not necessarily the same size are similar. And similar is denoted by this little enye. Now, two polygons are similar if 1. Corresponding angles are congruent, and 2. Corresponding sides are proportional. So, for the first one, it says that corresponding angles are congruent. That essentially means that you have angle, 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 which is why we don't say that angle, angle, angle proves two triangles are congruent, because it essentially means that they are similar. Now the second criteria says corresponding sides are proportional. Now when they say that, it means if you take the ratio of the two sides that are corresponding to each other, they'll be the same. Or if you take, say, the two right sides and compare that to the two bottom sides, their ratio should be the same. And that's called a similarity ratio. So for example 1, it says that if these two are these two similar? If so, write the similarity ratio. So the way we check that is, notice that first all of the angles are congruent to one another. They're all 90 degrees. Then what we're going to do is we can compare these and make a similarity ratio in two different ways. One, we're going to look at the smaller shape, ABCD, and say that that ratio is 20 to 36. And when you simplify that, that turns out to be 5/9. Now we're going to compare that to the rectangle EFGH, which is 30 50-seconds. And if we simplify that, see, they both have a 2 in common, so that gives you 15/26. Now notice that 5/9 and 15/26 are not equal to one another. And because they are not equal to one another, that means that these two shapes are not similar. The other way you could have looked at it is to compare, say, the right side to the right side. So 20 divided by 30. So that's the right side to the right side. And then we're going to compare the bottom side to the bottom side. So the bottom of the small side is 36. And the bottom of the big side is 52. So this obviously turns out to be 2 thirds. And the right side, this turns out to be 9/13. So obviously these aren't equivalent in either case. For number 2, it says, are these two similar? And in this case, they're also not. The reason being is because the angles are not the same. In trapezoid, in rhombus, RSTP, notice that we have angles that are 100 degrees, and if this is a quadrilateral, that means there has to be 360 total. That means that this angle must be 80, and this angle must be 80. clearly it doesn't match rhombus WXYZ because this is 95s and not 80 or 100. So for example 3, since the figures below are similar, find the values for x, y, and z. So I'm telling you that they're similar. Now the ratio between, say, the two left sides. So if we look at the two left sides, we have this left side of the trapezoid, and we have the left side of this trapezoid. So if we compare these two, that ratio is 6 to 8 for the small one to the big one, and that's going to be equal to the ratio of the two bottom ones, which we'll do in blue. Okay. Now notice we use the 6 from the left side in red, so we're going to keep that blue one and keep the smalls on top. So 12 divided by x, and now we're going to take the cross product and find out that 6x is equal to 96. X is equal to 16. Now we're going to do the same exact setup for y and z, and we could still use this same ratio. So I'm going to keep 6/8, and I'm going to set that equal to y divided by 6. Notice I'm using the two right sides. We're going to take the cross product again. 8y equals 36. Y equals 36 divided by 8. Y is equal to 9/2. Last but not least is for z. Again, we can use the same exact ratio. Equals. Notice the small side on top is z. Divided by the big side on top is 10. So 8z equals 60. Z equals 68, which simplifies to 15/2. So try these 3 problems. When you're done, post them to Edmodo. That's all for now. See you guys next time.